Basically what we're going to do is, this is an introductory course on the very basics of sprinkler systems, how sprinklers work, where they work, what they do best. And so basically what we're going to do is kind of guide all the way through the system from the sprinklers themselves all the way back to pretty much the water supply. So to start with then, and again, with such a group such as this, you can follow right along in the handout that I gave you, but let's not hesitate to ask a question, have a conversation. Really what I'm basically trying to do here, what we're going to do is, as our learning outcomes, is we're going to talk individually about and identify the various components of the sprinkler system. And we'll talk a little bit about the regulations in NFPA 13 that govern them and kind of how they interact with other components and the other components in the system. We'll also describe the different types of sprinkler systems that are out there and the different types of sprinklers in particular. So we're gonna look at all of the components, but we're primarily going to spend quite a bit of time with valves and sprinklers, mainly because that's what Viking, as a manufacturer, that's what we specialize in. We've been for over 80 years or so, we've been making sprinkler valves and the actual automatic sprinklers that deliver the water. So each one of these little components plays a crucial role in the overall success of sprinkler system operation. So to start with, the most important thing you can remember here is, as we go through any of these seminars, and especially as we go through inspection, testing, and maintenance, or introduction, sprinkler systems as a whole have been being installed for about 100 years now in the U.S., maybe over 100 years. And in general, they were used as property protection, basically used to protect factories and mills in New England is where they started. And then they just continued as a recognized practice, a recognized way of protecting property. And then over that time, regulations had built from insurance companies, and then insurance companies getting together and saying we should write standards that are applicable throughout the country, rather than just a different one for maybe Miami and then one in Fort Lauderdale. And I mean, up in the Boston area at one time in the early 1900s, there was somewhere around a dozen different installation rules, depending on the city that you were in. And so it got to that point where we needed to put them all together. So, but as a matter of practice over all that time, sprinkler systems have a 95% success rate of doing exactly what we want them to do when we want them to do it. And the only time we want them to go off is when there's a fire in that building. And so they have a 95% success rate of achieving the goal that they're set out to do. And we're going to talk a little bit about that goal and objective as we talk about the different types of sprinklers that can be used and the different types of systems, because there are different goals sometimes depending on the type of system that you have, whether it's one that's going into a single-family residence, or it's going into a commercial building, or it's going into a warehouse. These systems can have very different goals and objectives, and we'll talk a little bit about what they are, as well as how the sprinkler design actually has changed over time to reach that goal. So in this particular presentation, in this particular time, we're going to look at these 6 component areas. We'll take a look at the sprinklers, the above ground pipe and tube, hangers and bracing, valves, fire department connections, and water flow alarm devices. So let's take a look first at kind of the use of sprinklers. When we're looking at a sprinkler, and we take a look at the deflector, we take a look at the frame arms, its orientation. NFPA 13 has very specific guidance as to how that sprinkler is to be used. Now, it's also important that when we look at the design criteria that's used for the sprinkler, what it's designed to protect, what we're looking for it to protect, is critical, because it's going to deliver a certain amount of water. And that certain amount of water is dependent on the size of the orifice of the opening of that sprinkler and the pressure of the water flowing through it. Right? There's a formula that we use for everything that we do in sprinklers. Basically, is Q, which is flow, quantity of water, equals K times the square root of P. So if I were to just leave this here, K times the square root of P, what this means is that the amount of water that's going to come out of this sprinkler is directly related to, and is mathematically related to, the K factor, we'll talk about K factors in a minute, times the square root of the pressure of the water coming out of that sprinkler. Okay? So I've got water coming down this pipe and it's coming up and out of that sprinkler. It's going to hit the deflector and it's going to come all out in this direction here. The amount of water that comes out is the K factor, that opening, times the pressure that comes out of that, that's feeding that sprinkler. Now, why is that important? Because underneath this sprinkler is a certain area of floor that it's responsible to cover. Okay? Maybe it's 130 square feet, maybe it's 225 square feet, maybe it's all the way up to 400 square feet, 20 by 20, that it's required to cover. And it's required to cover that area with a specific density of water. Okay? A specific amount of water is supposed to come out and spray around that whole 130 square feet, 225 square feet, whatever it happens to be. The amount of water is based on what's underneath it. The actual, all right, so I've got all these tables in here and they burn at a certain rate. If we set them on fire, they kind of, they get going and they burn at a certain rate, at a certain, what we would call is, at a certain rate, which requires a certain amount of water to put them out or control the fire. That's called the required delivered density. So we've burned, over the years, fire labs have burned certain things that are representative of this space. And that's the RDD. That's the required delivered density of water. Well, this sprinkler has what we call an ADD, or a capability of delivering water. The actual delivered density, okay, is going to be sprayed out of this sprinkler, depending on K and square root of P. That's going to be the actual water that comes out, the actual density over each of those square feet. Okay? So now, what we have here is, we have a sprinkler in the middle of our room, and we have all of this water, and we have this space that it's required to cover. Now, one of the things you're going to look into as you get into sprinkler systems, as we look into the specifics of sprinkler systems, you're going to come across hazard classifications, a discussion of what the hazard is, whether it's a light hazard or an ordinary hazard, group 1 or 2, or an extra hazard, group 1 or 2. You're going to hear that terminology being used. What's the occupancy classification? When it comes to storage, which we'll talk about on Thursday, we'll talk about the commodity classification. What kind of commodity is in there? Is it just kind of metal desks and things, or is it plastic furniture of some kind? All right, or is it foam plastics of some kind? All right, so each one of these particular hazard classifications has a density that is required over each square foot of floor area. For example, a light hazard occupancy is 0.1 gallons per minute over each square foot. Now, if I've got 130 square feet that it's covering, then that means that that sprinkler has to flow 13 gallons per minute. So how much pressure can I flow through that K factor in order to get 20? It's going to be a higher pressure. The K factor is not going to change, so the pressure needs to change in order to get that coverage. Okay? So this is how sprinklers have developed over the years. We'll come back to that discussion.
Jim, somebody asked online, and I kind of sort of know the answers a lot, but how many different K factors are there K factors infinite, or is it a...
No. K factors are not infinite, and actually we're going to show you a slide a little bit later on that actually pulls in the K factors and their range, and then we'll talk again about, as we show you the characteristics of the sprinklers, kind of a nice lead-in to the use of sprinklers. There are 6 characteristics that I want to talk about specific to the sprinkler. Okay, and that's really crucial. I mean, just that little math that we were doing right there, all of these things in that little piece of equipment there, we need to talk about all of these things when an engineer is selecting a sprinkler, or a plan reviewer is reviewing a sprinkler, or the inspector is going out and making sure that what the engineer designed and the layout technician put on is actually going into the building. All right? So we need to be specifically concerned with this particular piece. All right? And we have a lot of rules in NFPA 13 that govern that. So let's take a look at it by virtue of kind of just moving through here. Let's go through the list. And first, let's take a look at that temperature rating. Now, the temperature ratings of these particular sprinklers have also kind of evolved over the years. But basically, one of the things we're looking at is, here's the what's the maximum ceiling temperature that we can anticipate in this particular space? Okay, so in this particular room here, nice training room, air conditioned, what's the maximum temperature you'd expect in this particular room? Before anybody's running out of the building here just going, it's too uncomfortable. It's like
80
yeah, right. 72. I'm going to start getting uncomfortable once it gets over 72.
Right.
That's what mostly we design our spaces, right? Any kind of occupied space, whether it's an office building or anything else, we're trying to maintain it where? Probably around 72 degrees. So in a room like this, basically the maximum ceiling temperature, okay, the maximum ceiling temperature is going to be around, so that's 72. If we start getting fire in there though, all right, that's going to go up pretty quickly. All right, so the maximum ceiling temperature, the temperature rating, now this becomes critical because we got spaces that it's going to get higher than that, right? Yeah.
Sorry, quick question.
Sure.
When you're determining the maximum ceiling temperature, you talked about probably 70 degrees and the size of the room. Do you take into effect, into factor, the contents in the rooms?
Yeah.
Like there's a lot. Okay.
Yeah.
Then you would determine that from what's inside of the room.
You're going to determine that because you can see here, there's 625 degrees maximum. No, that's never anything. You know, nobody. But this is when basically. Your maximum ceiling temperature is how quickly it's going to get to that. But what you have to also be aware of is, especially in Florida, in an unheated in an unventilated attic space, or even in a ventilated attic space, what's your temperature going to be?
100.
Yeah, in the summertime. Yeah, I mean even up in New England, you get unvented attic spaces. You get a couple of 90-degree days up there. The sun beating down, and you're gonna get up that high. All right, you're gonna have 100 plus. And so while it doesn't really play a huge issue down here, you can have certain industrial processes and things like that, that right above that space, or heaters in a given area that are pushing out a lot of space heaters and things like that. Again, not something you might run into down here in Florida, but we run into quite a bit, you know, heating the space up. So you may, in localized areas, have temperatures that go up even above 150. But certainly down, you know, when you get into unventilated attic spaces, you're gonna be running up in these temperatures easily. So if you've got sprinklers that have to go up there, we need to make sure that the temperature rating of the sprinkler corresponds with what the maximum temperature of the space is going to be. You don't want to be putting these lower 135 to, you don't want to put a 155 degree temperature rated sprinkler in an unventilated attic space. Don't want to do that.
Jim, we've even moved a lot down here and pushing very heavily through the engineer and design teams. Is the intermediate temperature
Yes.
as the standardized because of ambient temperature.
Mm-hmm.
And so that's one of the things that we've had to kind of consider down here. We realized even in an air-conditioned space, with the concealed head in particular, we're above the plane of the ceiling,
Mm-hmm.
and we're finding temperatures are very consistently
Yes.
over 100 degrees, even with AC below the ceiling. So we've made a very, very strong recommendation to everyone to go to intermediate temperature as their go-to sprinkler.
And that's not unusual, okay? Especially in the concealed spaces. All right, we're going to talk a lot about that on Thursday morning. We got a whole session on concealed space protection, and we'll talk a lot about that temperature rating, those temperature issues that come up with that. But this is clearly kind of the benchmark that people are moving to, and it's actually its classification is an intermediate temperature. Now, most of the sprinklers you're going to see nowadays are glass bulbs. Most of the stuff. Now, Viking does have a line of fusible link type sprinklers, solder link type sprinklers, okay? But they are color coded, so it's important to note which type of sprinkler is being used, whether it is a solder link or a glass bulb sprinkler. The easiest ones to find, the easiest ones to determine whether or not they've got the right you got the right temperature rating are going to be the easiest ones really are the glass bulb sprinklers. That's going to be yellow or green. And here's what you're looking for.
Are the fusible links colored as well, Jim, or no?
The fusible links will be colored. If you take a look at this, the color code is going to actually be the color of the frame. It'll be painted on, the frame will be painted as that. It should be anyway, okay? So the color code here on a fusible link should somewhere in there have this color code on it in order to comply with 13, okay? All right, so what we have then here is, this is the kind of the Easter egg colors that we have on our fusible links, and these glass bulbs are indicating the temperature rating. Okay, and the fluid in there basically expands. It reacts to the temperature at a certain rate, at a certain temperature, and it will begin to expand and break the bulb and operate the sprinkler. With the solder links, the solder will begin to degrade at a certain temperature, depending on what the rating is, and then it will release the metal pieces of the link and operate the sprinkler through this opening right here. Now, here's where we get into some of those localized areas that we were talking about before. You can literally have a unit heater blowing directly on, it blows out into the space. And because I've got sprinkler spacing requirements to deliver the water, I may have a sprinkler, it's not gonna work, right in that given area, right in front of it, okay? So NFPA 13 says that if I've got a sprinkler in that location, or I've got a sprinkler that is within heating location here, of a downblast type of a heating duct, then I'm going to need to consider what the temperature is coming out of that, in that airflow, and consider what I'm going to do with my sprinkler. So just because it's in an office environment doesn't mean that we're not going to be putting intermediate temperature sprinklers in certain spaces.
So it's just the space plus the supply.
Pardon? Plus the
Supply.
plus the supply.
Yeah, I'm saying the heating supply.
Yeah. Right. So what you're looking at in certain circumstances, like with my unit heater, it's going to say basically the standard says in a unit heater for a 7-foot radius around that, I have to have high temperature sprinklers around a unit heater. Now, out in the direction of flow, so if I go back to this one here, which is in the direction of flow with that heater, I'm going to have an intermediate temperature sprinkler. Okay, so if you go back there, then basically what you should be seeing is the color coding should change in that direct area. So yes, it's where the flow is coming out and how close it is. Now that changes when it comes to ceiling diffusers. This is basically going to be a radius around this entire thing, and it doesn't extend as far out as the unit heater, because these just kind of diffuse it out and it goes down. And so usually it's I want to be careful, but it's about a 2-foot. It's about a 2-foot radius around around a diffuser like that. But again, NFPA 13 gives you that kind of detail, gives the designer the kind of detail to select the right sprinkler. So let's take a look at the second characteristic then of a sprinkler, and that's what we call thermal sensitivity. Now, thermal sensitivity is different than its temperature rating. Okay, the thermal sensitivity is the speed at which the sprinkler will react to the temperature when it gets to its operating temperature. So if I have a 155-degree rated sprinkler, how fast is that sprinkler, once it gets to that operation, once I get a fire going and it gets to that operational temperature at the ceiling level, how quickly is that sprinkler going to respond? Okay, and that's what we call its RTI, or what we call a response time index. Now, all we really need to know in our response time index, or what you need to know, because the math behind it is quite extensive, is the sprinkler listed as a quick response sprinkler or a standard response sprinkler? You'll hear those terms being used as well. All right. A quick response sprinkler has a fast response link. Fast response link responds to the fire faster, or it responds to the fire faster than a standard response link. Let me show you what we're talking about here. It's important to know this because since 2001, NFPA 13, the book that governs the installation of sprinkler systems, has required listed quick response sprinklers in light hazard occupancies. Okay, so if I have an office space considered a light hazard occupancy, or if I have a hotel space considered a light hazard occupancy, it's required that I use quick response sprinklers. I cannot use standard response sprinklers in these spaces. Okay, so what is a quick response and what does it look like? Well, we first have to take a look at this operating element. All right, and as I said before, you take a look at these operating elements, and here's the glass bulbs, here's the solder links, type of element. And again, these are going to respond because it's a red color. It's going to be an ordinary temperature sprinkler. All right, probably around 155 would be its range of heat. Same thing with the solder link sprinklers. QR fast response sprinklers come in a couple of titles. Fast response sprinklers are quick response sprinklers, first of all. Early suppression fast response, which is an ESFR. We'll talk about those in a couple minutes. quick response extended coverage, which is a different type of sprinkler, or residential sprinklers. Sprinklers that go and protect, go into and protect residential areas or residential occupancies.
So there is a difference when somebody says a fast response sprinkler versus a quick response. They could be talking about a couple of different sprinklers.
Yeah, well, yes, you can be. The technology gets a little, or the terminology gets a little, it's a little confusing sometimes when you're talking about these. Right? We do have Viking actually has a paper on the difference between quick and fast response. But fast response typically is used to describe the link. It's a fast response link, it's a standard response link. And that's based on how quickly it's going to respond to a fire. The sprinkler that uses the fast response link is usually termed a quick response sprinkler. Except when it comes to the ESFR, which is early suppression fast response. So it gets a little confusing. The term typically used for the sprinklers that are going in are quick response sprinklers. And a residential type of a sprinkler is also a quick response sprinkler. So the big difference that you'll find then when you're looking at when you're trying to identify, if you were trying to identify these simply by just kind of looking at a given sprinkler, would be the thickness of the bulb. Okay? And this is just simply indicating, this is a fatter bulb, squatty, fat bulb, and a very narrow bulb indicates that that is a fast response link. Okay? That is a fast response link. So that is most likely, some circumstances maybe not, most likely a quick response sprinkler. Right? And this is a standard response. Now remember again, the other than light hazard, okay, residential sprinklers require, or residential areas usually require, if you're using that design, you can protect it with a residential sprinkler. But light hazard occupancies, anywhere you go that is considered light hazard, classrooms, office spaces, restaurant seating areas, things like that, these are all considered light hazard occupancies. So as a designer, you should be using, speccing out quick response sprinklers. All right, let's take a look then. Again, we talked earlier about this K factor. All right, we showed you earlier kind of how the K factor has an impact on the overall ability of the water to deliver water. Well, the K factor is simply a description of the orifice size, and it's not only the orifice size that impacts the K factor, but it's the ability of water to flow through that orifice. So a larger orifice actually flows more water, but there are other characteristics that go in to K factor as well. So let's take a look at this orifice size. So here I have 3 different sprinklers, and you can see that they have very different orifice sizes. All right? We don't know just looking at them what they might be. We can assume some of them. But each one of these sprinklers also has a K factor that goes along with it. The ability of water to flow through that particular sprinkler. So if we flip them around here, we see that in this particular case, we've got the VK472, and it's a little hard to find where it is here. There. Looks like it's a K. Oh boy, I can't even see that one. K6? K5? 5.6? 5.6? Okay.
What's the VK number, Jim?
472. It should be a 5. But as we look at this one, then we come over here. This is that middle sprinkler was an ESFR, VK500, K14. The one on the far right was a K factor of, it looked so much easier when I was doing this, K18, K18.
And the 472 is a 5.8.
5.8, okay. So we have a 5.8 K factor, a K factor of 14, and a K factor of 18, 18.6 looks like. Smaller, middle, large. And they even go bigger than that. So in NFPA 13, we see that the K factor here, the nominal normal operating K factor, the normal sprinkler that you will see out there, installation-wise, is the K5.6. Now that K5.6 has a range. That's where we saw what the VK, what was that, 472, Will, that we were looking at?
Yep.
Is a 5.8. So that's in the range of this, of a K5.6, nominal K5.6. Okay? So this is basically the baseline flow, 100%. Okay? This is our baseline flow. Now we also looked at a K14 sprinkler, right? On that last slide. So taking a look at a K14 sprinkler, as opposed to this, 250% of the flow of this particular sprinkler can flow out of a K14. A lot more water can flow out of that. More than 2 times the amount of water can flow out of a K14, 2.5 times. Then we get up to our K18, which is the nominal K factor 19.6, and it's 3.5 times the amount of water. If you get all the way up to a K28, very large orifice, it's 5 times the amount of water can flow out of that. So if we had a K5.6 sprinkler that was capable of spraying 20 gallons per minute, how much can a K8? Yeah, 100 gallons a minute. That's a little hose stream up there. All right? These are they're basically used for high challenge storage type fires. All right? That when you get up into these ranges, these are the type of sprinklers here that you'll find in protecting storage occupancies. Okay? Mainly because fires tend to grow very fast in those occupancies, and we need to get water down through that fire plume very quickly. All right, so that's when we get into, but we can also see that we have smaller orifice sprinklers, and they're designed to deliver an equal amount of water with a smaller K factor, same pressure. If you shrink that K factor. All right, installation orientation. Here's an easy part. There's only 3 orientations you can have, okay? Upright, dependent, and sidewall. An upright sprinkler characterized by either a fairly large deflector where the tongues coming off of the deflector are pointed down so that it collects the water as it's coming up to hit the sprinkler and then sprays it down. So this is a characteristic, this is the characteristic of an upright sprinkler. Look for the fins here, pointed down. Look for a larger, probably more solid looking deflector, so it's collecting all that water. The pendant sprinkler, more of just a flat disc, a lot of deeper grooves in it, separating the tongues from it, so that it's just taking water out directly and spraying it right out, creating the spray pattern there. And then sidewall sprinklers, simply taking the water coming out of the side, hitting the deflector here, and then going in a number of directions here, but it's being then redirected by this flat, smooth space of the deflector on top, so that it comes out into the room.
Question: when would you use a side wall pendant? Is there on a narrow hallway or something, or why would you use that?
Why would I use a sidewall sprinkler?
Instead of the other 2, yes.
Instead of the other 3. I'll tell you, a perfect example of that is in a hotel room. Okay, I'm using it in a hotel room to save piping, basically, going into the hotel room, and maybe I don't have the capability, actually, of going through, you got concrete floors, right? And you don't have any kind of room to move in your concrete floor area to go put a sprinkler in the middle of the room. So instead, they bring it in from the corridor, they bring the piping in from the corridor, pop one in the bathroom, and then pop another one right out, protecting. You'll see that a lot. Next time you go into a hotel room, just look on the wall. That's usually the way they're protecting them.
And you have the capability to have on one wall and the other one, so it's sprayed both at the same time.
If you have a particularly large room, you can protect it with sidewalls from each side. Yes, it's a bit of a challenge, and you got to pay attention to how you space them so that you're not spraying into, you're not, kind of competing with each other in certain areas. There are rules as to how you stagger them along each wall, but you're right. You can, on those very large spaces, create sprays coming from each direction. So, in this particular case, we're going to take a look at it. So, if we take a look at each of these, here's a spray pattern from a standard response sprinkler. Here's a spray pattern from a sidewall. All right, or a standard spray sprinkler, I should say. All right, pay attention to, when we're looking at the standard spray sprinkler, just pay attention to the way that the shape is building. Okay, pretty conical in its shape. Directing it right down. This is coming out of a pendant sprinkler, coming right down into the area protected on the floor. Sidewall sprinkler, on the other hand, is kind of shooting out water as far as it can reach based on the deflector, pressure, things like that. So those are the different flows. And again, they're just there to kind of show you the difference in where we're going. Now, if I had an upright sprinkler too in that particular area, you'd be seeing the same kind of shape of flow of the spray pattern as you're seeing on the left. So the water distribution characteristics then come down to a way of describing how that sprinkler spray pattern has kind of changed over the years, but also how does it distribute water out to cover that particular floor area that's necessary to be protected. So over time, we have developed a series of different types of sprinklers that you may encounter in some of your buildings. The old style sprinkler, we'll show you a picture of that here in a minute, is one that was used up into about the 1950s, and then we went to the standard spray. All right, and then extended coverage. We started to get out into larger spaces that could be covered. Then sidewalls and extended coverage sidewalls, residential sprinklers, and then finally, some really creative spray pattern development to protect attics with sloped roofs, so that we don't have to put as many sprinklers in that space. We can save water, we can save cost and everything else, simply by using these specialized sprinklers. So here's an example of an old style sprinkler. Old style Viking B sprinkler, 1942. And so basically what this particular sprinkler relied on was it actually used the ceiling a lot to create its distribution pattern. So it would catch, the water would come up out of here, hit the deflector, and about 20% of the water that was coming out of here would then go down. And then the rest of it would go up. Oh, I got a ceiling line right here. Excellent. And do this. Okay? Now the problem was you didn't get a whole lot of coverage out of that. So you had a lot with these older sprinklers. The old style sprinklers, you had sprinkler spacing that was pretty tight in order to make sure that you got total coverage. All right, so that's the old style. Then we moved out into, we created, developed a new style. 1953, 54-ish. And you can see the big change here. The big change was the deflector size. Now we were capturing almost 100% of the water that was coming out. We were capturing it and redirecting it down. And then, so basically, over that time was the standard spray sprinkler. These were standard use from the 50s on into, the 70s or so, when we started to see development of different types of sprinklers. And so, when it comes to this standard spray, now flip it around as far as a pendant sprinkler is concerned. You take a look at what's happened over the decades here in the 1980s, and this is a pretty accurate comparison of the size of all of these sprinklers now. The 1980s technology, that older style that we just saw, okay, fairly decent size. In 2000, Viking came out with what they called the small frame sprinkler. Same water distribution characteristics and everything, was just a little bit smaller. And then we're about to launch what we call the XT1. That's coming out very shortly. It's even smaller, lower profile. All right, crank these things out, really easy to install. Got a special wrench that goes along with them. But this is coming out in even smaller. Same basic principle though. Delivers water in the same standard spray pattern. Then we have extended coverage sprinklers. Extended coverage sprinklers were designed to take the type of the water spray coverage of a standard and extend it out a little bit further. Now, why would we do that? Why would we use extended coverage sprinklers?
Big warehouse.
Big warehouse, yeah.
Larger spaces.
Fewer sprinklers to install in the same area. Yeah, little money. Most of the time you ask a question about why would we do that, it's money. All right, it's how can we save money installing these? Right, that's a huge big issue. All right, so instead of 144 square feet, 130 square feet, something like that, now we can actually design out to, in some cases, sprinklers that have 200 square feet of coverage. All right, 20 by 20. So that starts to really cut down almost by a third the number of sprinklers that you're going to be installing. Challenges come, obviously, if you're going to cover that large area. Remember the calculation we showed you earlier. You got to have better pressure, all right? Or you got to have a better K factor in order, a larger K factor perhaps to get that further out. So when we start to take a look at this, then those are possible, but again, you need to be careful with the design parameters that you're putting in for those sprinklers. So we're here again. So we recognize that one from the sidewall video. Now take a look at the extended coverage. Okay, so that little change in the deflector, okay, took it from this to that.
The difference in deflectors, is it wider, the grooves are smaller or shorter? Or?
Great question. Great question. If you take a look, let's go back to that. Okay? And then we'll go back to, maybe we can see it back a little further. Remember, we go back to that. So now, deep grooves, smaller deflector, and you go all the way out to this bad boy, and it's much more solid. The grooves are shallower. You take a look at it, it's hitting more of a flat plate to create that spray pattern. So once again, you take a look at those, and now you're out to this greater area. Now we get into residential. Now, residential sprinklers, or the concept of protecting residential occupancies, came along in the 70s, in the mid to late 70s. We started to see that one of the biggest challenges, greatest loss of life in fires was occurring in residential occupancies, single-family residences, apartment buildings, and things like that. They weren't being protected with sprinklers. So the challenge here was to develop a sprinkler that could be installed relatively inexpensively in a residential occupancy. And again, with a residential, once again, in order to cover these areas, you had to have and provide life safety, whereas other sprinkler systems were basically designed for property protection. Everything else we've been talking about up until this point. This particular sprinkler was designed to provide, and the whole system was designed to provide enough water so that people could, to the system, so that people could get out of the building and survive. And then if the system ran out of water at that particular point in time, that was fine. It was more of a life safety system, get the people out. So in order to do that, then you had to have a sprinkler that was capable of QR. You can see this characteristic right there. A broader spray pattern to cover a larger area, not necessarily because they needed that extended coverage, but if you take a look at a living room, if you take a look at a standard room living space in a home, where's the fuel load? It's out along, well, it's out along the wall in a living room. Where is it? It's out along the wall. So we need to make sure that our sprinkler spray patterns for a residential sprinkler was again had that flat spray pattern that had what we call higher wall wetting characteristics. All right, we would get it on the wall, because if that fire starts up the curtains and things out there before the sprinkler operates, we don't want it to get above. We don't want to get it going up above the spray pattern.
28 inches.
Right. Excuse me.
28 inches.
Yeah, it depends. Yeah, it depends on what you're right. Somewhere in there, I think is the far end of the listing. So again, when you go to now this is going to look very similar to the other, but that's a residential sprinkler. So there's a slight difference in the extended coverage, but pretty much the same kind of a spray pattern. You see, this is even higher. This spray pattern goes even higher on the residential ones. Now we get back into kind of a specialized we get back into the standard spray sidewall sprinklers. And these can be used. These are either this can be standard response or a quick response. This is a interesting, seldom used type of a sprinkler, which is what we call a vertical sidewall sprinkler. This one actually sprays water, comes out, sprays water out this way. This one actually, it comes up and the deflector is bent so that it just takes it out and directs it out into the room, just like it's facing you right now. This particular sprinkler would spray water out into the room. Up, hit the deflector, and head out. Used to be, I mean, you're not going to find too many of these out there. It's not an easy installation. It's not a common installation, but there are some there, especially in renovations. You find a lot. You found it in New England when they renovate old mill buildings. Sometimes it's easier to come in there with vertical sidewalls to protect certain spaces. Then we get into CMSA and ESFR sprinklers. This is control mode specific application, and that's an ESFR. Does it look the same? They look the same? They kind of look the same. It's kind of hard to tell the differences between them sometimes. You have to take a look at the overall at the deflector to find out what it is. These do have two very different capabilities, though, where the CMSA, or what is called a control mode specific application sprinkler, is designed to control a fire, typically used in warehouses and high challenge warehouse type fires. But it's intended to control a fire. Now we haven't really spent a lot of time with control versus suppression, but here's where it changes. A lot like residential took the concept and changed it to life safety. The ESFR took the concept and said, we're going to suppress the fire as opposed to just control it. Because for 100 years prior to that, sprinkler systems had been designed so that basically they control a fire. You put water on the fire, you wet around the area, and you wait for big water to show up from the fire department to put the fire out. Well, with the development of the ESFR, or Early Suppression Fast Response Sprinkler, that changed the game. We were then able to say, when you look at the K factors coming out of, remember we got down to K 25 and 28, 100 gallons a minute coming out of these guys? All right, this one in particular is fast response. It's a fast response acting sprinkler, and it basically puts 100, anywhere from 80 to 100 gallons a minute down through the fire, down on the fire. And it's designed to take that fire growth and just drop it. So then you get into the special service conditions. And these are our special attic sprinklers, or in this particular case, that one is a institutional sprinkler. And it's designed to be put into places where we're concerned about either damage to the sprinkler or individuals injuring themselves by trying to hurt themselves using a sprinkler, maybe hanging themselves, things like that. So it has a very low profile, and you can't really get to it at all. These are the attic sprinklers that we were talking about earlier, where we actually can take a pitched roof attic and spray water directly from one line of sprinklers going down the peak. We can spray it down each side rather than putting sprinklers of 2 rows of sprinklers going up the pitch of the roof. We actually can take one line of sprinklers and begin to protect the entire space. This is what we call the hip sprinkler, which you've got a hip in the roof. This actually will spray down that hip line, ridge line as well. So the question then becomes, and again, we'll talk about these a little bit more on Thursday, but then there is a special design of a sprinkler that Vikings called the coin, or the combustible interstitial space sprinkler. So if I've got space above this ceiling line, which I do, there's space above this ceiling line. The question is the space above this ceiling line combustible, or is it non-combustible space? Okay, and NFPA 13 says in certain circumstances you can eliminate sprinklers if it's a non-combustible space. But what if it's a combustible space? We're using a lot of that type of construction now.
And who determines that, Jim? Is that in NFPA as well?
Yeah, NFPA is real clear, and Thursday morning we'll talk very specifically about how that space gets defined as a combustible interstitial space, because it does get defined that way by NFPA 13. So yeah, it basically, I mean, just for today's purposes, let's just say it's a wood truss construction, or it's the I-beam, composite wood,
right?
Okay, I-beam construction. So stuff like that would require sprinklers in it. Okay, but now we're talking about a space like this. It's all over, everything above this ceiling line, but now it's compressed into a space like this. Well, how are we going to get water out into that area? And remember our standard spray sprinklers, what do? They have that cone shape. Well, how much of that spray pattern is actually going to develop, in the first 3 feet of that particular spray? Well, not as much as it would be if it had the full, 10 feet to get to the floor. So we've developed sprinklers for the combustible interstitial spaces, and you can see already, what's that characteristic look like? Yeah, it looks like the extended coverage sprinkler, right? It comes up, hits this big old disc, okay, about that much around, all right? And it goes off and it creates a spray pattern that's a little bit flatter, covers all that out into that area. You can also see here that it doesn't come in standard temperatures, right? There's nothing red there, it's the yellows and the greens. So it's intermediate temperatures. You don't get these in standard. Then we also have to be concerned with, finally, we have to be concerned with corrosive environments. Now, corrosive environments exist in quite a few different locations. One of them being right here in South Florida, right along the coast. We put sprinklers in places like parking garages. Yeah, those are considered to be corrosive environments because of the salt air. So when you look at NFPA 13, it considers outdoor parking or parking garages in the coastal areas to be corrosive environment. Do we require sprinklers sometimes to be installed protecting balconies in residential occupancies? Yeah, the fire code, the building code, and the fire code have required that now have requirements about this for some years now. So the problem is, how do we protect our sprinklers in those corrosive environments? Well, for a long time it was coat them with wax. You could coat them with wax because it's not just the outside environment here. It can be in manufacturing and things like that where you run into acid sprays and things like that that you need to be careful of. Then there's the ENT covering, and it's an electro. What is it, Will?
Nickel Teflon.
Nicholas Teflon. Okay, there's the one. All right, thanks, Bill. That wasn't a test. I really couldn't remember what that term was. But thanks for covering me on that one.
So we use that a tremendous amount. You nailed it, so I didn't even have to say it. The balconies down here, we've got a tremendous push for those. We're finding that the poly-coated heads, with the fact that the threads are not coated, and also along the sides when they put the wrench on it to screw them in on the balconies, we get corrosion at such an early stage in that we're trying our best to move heads more and more to that ENT. So if any of you guys do have properties that have any sort of outside down here in South Florida, I highly recommend the ENT.
The ENT.
That's the go-to head.
And finally, much more expensive is the stainless.
Absolutely.
But I mean, it's possible. Those are your three options in a corrosive environment. Really.
One thing, guys, wax coated is standard response only, so we'll never have that in the new construction world down here any longer. The only time we're selling that wax coated head is really replacements, and I'm almost always moving people to the nickel Teflon, the ENT head at that point as well. Yeah,
we've had issues in a university up in New York where they actually had water. It wasn't the environment. It was the water supply. That it was a private water supply for this university that they had.
It was corroding the head.
That it was corroding actually up into the pip cap, everything, and so they were experiencing leaking. And the only reason we knew that it was one of the ways we determined that it was actually the water supply as opposed to anything else is because there were 3 different manufacturers' sprinklers in this particular space, or being fed by this particular water, and they all were experiencing the same corrosion. So we're going, hey, wait a minute, that's not a manufacturing issue, and it's not an exterior corrosive issue, because this was kind of like in a light hazard occupancy area. It was I think it was a daycare center or something along those lines, but it was goobering up our pip cap and everything right in this area. So we basically took that sprinkler. We basically took that particular sprinkler because they needed to replace it with an exact replica of that for spacing and everything else. And we were able to, because we've just started offering this within the past couple of years. ENT's only been around, what?
4 to 5 years.
4 to 5 years. And so basically we've said, yeah, we got a drop-in replacement for you, but you got to go ENT to do it. So, and this is one where you probably will find it used down here extensively. When you're dropping in from a wet pipe system into an unheated or cooled area, freezers, cool warehouses, things like that, where the temperature is going to get down below 40 degrees in the space that you're protecting. Okay, so food warehouses, things like that. So basically, what this does is there's no water in this. This is a dry pipe or dry sidewall into that particular space. All right, and basically, go to this. Yeah, basically you have to measure it's either the exterior wall or it's the wall of the cooler freezer type of a thing, that from the face of the fitting, we need to be able to separate this from the water. See, this is a water-filled pipe, and this is the freezing area right here, or the exposed area if it's outside. Sometimes we use these to protect balconies up in the Northeast where they could experience freezing. You have this arrangement. One of the things we're concerned with, though, is if this water pipe is not far enough away from the frozen area or the unheated area or the cooled space, you'll get creep of the cool temperature. This will conduct all along that pipe, and it will, if it's too close, it'll create an ice plug right there. So this distance is critical to the successful installation of a sidewall sprinkler. Now, when it comes to coming down through to an insulated freezer, then kind of similar. We have a distance here. We have a clearance hole around it. We can actually also insulate it so that it doesn't creep beyond this space here. We seal around the piping in the freezer. All right. As you know, over the years, we can paint it any color you want. All right, that's not the best. Those aren't the best color indicators, but we can paint your sprinklers any color you want. We've been able to recreate any of the fine Benjamin Moore weird colors that they have. We can create that.
So the guys
in the manufacturing process.
Yeah, the museum here, guys, we can do literally any color, not like pink, blue. Any color you guys want to match up, we can match it up for you. With the plate or the frame style.
Yes. One of the best examples I saw of that was years ago they retrofitted a Gothic cathedral at Yale University that had a Kelly green ceiling, and you can't tell the sprinklers are up there. They completely matched the color. We completely matched the color on the disc.
We actually can do a color match, Jim, at the factory. So if there's this very specific color like he's talking about, you guys can send that into us. It does take a little bit extra lead time to get it done. But if there's a head color or a wall color you guys need specifically matched there, we can take care of that for you as well. Yep.
So the last type of sprinkler then that we'll talk about before we get into some of the other some of the things that go on around the sprinkler, and then is an in-rack sprinkler. And these are designed in rack storage. These are designed to be installed when it's required to put sprinklers in the racks itself to deliver protection directly to a burning commodity that's within the rack. Because sometimes these can get up as high as 45 feet or more. So it's not enough to have sprinklers at the ceiling line. We'll talk about this on Thursday when we do storage sprinklers. But this in particular sprinkler gets installed in the racks itself, in between the racks. And one of the reasons that this disc is there is not for collecting heat, but it's for protecting it from spray from above. Because you don't want spray from the sprinkler above to get on this fusible link, because that delays the operation. Then, of course, with some of our sprinklers, we, those that are installed in racks or in areas where they could be damaged, you want to you may need to get a guard placed on it. Now, this needs to be compatible with and listed for the use with that sprinkler. All right, just can't put any old cage on there. And then we get around to this when it comes to making the sprinkler look pretty in the space. This becomes an aesthetics, is when we have flush type sprinklers, or we've got sprinklers that you create a hole to come through the ceiling, right? So you can either have a listed concealed sprinkler that's totally hidden, or you can have a recessed one that's just a little bit hidden, or you can have a fully exposed sprinkler, but you gotta kind of get around that, make that hole look pretty. Nobody likes that thing ugly. So the escutcheon cup that goes around it is then specifically used in conjunction with the sprinkler itself. So you got to kind of build that all together. So the question then becomes, as we look at concealed sprinklers, and this is where we were saying there's any number of different methods to or modes that we have here for concealed sprinklers, even down to domed concealed sprinklers. We have sidewall concealed sprinklers as well. You might see something that looks like this on a sidewall that is actually a sidewall concealed sprinkler. But the big question then becomes, well, man, that's a lot of sprinklers. And in fact, we did, Will and I just went through the exercise of, wait a minute, what is that K-factor? I can't read it, but I can read what's called the SIN number, the sprinkler identification number. So in all of these sprinklers, how do I identify them? What's the quickest, easiest way to identify a sprinkler if I'm holding it in my hand? And the best way to do that is through the SIN number, VK3021. Now that happens to be the XT1 sprinkler, the real small one that I showed you, the 2020 technology. This happens to be just about to launch, okay? But you can find out all the information you need about that sprinkler by getting that number, and then you can go to the Viking site and go VK, and this is what it is. Type in VK3021 or VK, what did you do? You typed in VK740, whatever that was that we had. Okay? And you found out all the data, you got the data page, and any information you need can be found on our site.
That's like a serial number.
Pardon me?
A model number.
Yeah, it's exactly that. If you're not, or you can just try to read the hieroglyphics here on the sprinkler. This is pretty small. I had to blow this up quite a bit so I could read it. But you can see it's a, what? Standard spray pendant sprinkler. You can see also that it is a QR sprinkler. So if we turn this the other way, what kind of fusible link would you expect to see on it? The very narrow fusible link on it. It's 155. So what color would the bulb be? Red. All right. 68 degrees C, 17. It's been UL listed and FM approved. In the United States, that's a big deal. It has to be UL listed and FM approved. Elsewhere in the rest of the world, they have other approving authorities.
What does FM stand for?
Factory Mutual. And Factory Mutual is an organization. Yeah, you as an enforcer may come across Factory Mutual because they are enforcers also. They actually are an insurance company, and they do usually highly protected risks. They cover their highly protected risks, and they do not follow. If you've got a sprinkler system that is being designed in a Factory Mutual property, they will require you to follow the Factory Mutual guidelines for the installation of the sprinkler system, okay? They have their own written guidelines, and that becomes a pretty big deal when you start looking at how they protect storage, how they permit sprinklers to be designed. So they're not exactly the same as NFPA 13, they're pretty close, but there may be some additional requirements or some differences in what Factory Mutual would require you to do. All right, now, then we get into above ground pipe in the system. So all of our sprinklers are connected to piping. That's how we get the water to the sprinklers. So we're working our way back from the sprinkler. We've covered just about everything. We've covered just about everything we can with sprinklers. Now we're going to just take a look at the way the water gets conveyed to that pipe. Now typically there are basically three types of pipe and tube that are permitted by NFPA 13. All right, it's steel, copper, or non-metallic. And then non-metallic kind of gets broken down into CPVC and not necessarily polypro, but PEX is for NFPA 13D systems only. All right, the CPVC and PEX are going to be the ones that you really kind of get into. Steel pipe, whether it's galvanized or black steel, is very common. Copper, not so much. Copper in very specialized systems. I've only seen it used a few times, and it's usually in kind of museums or in spaces where they're actually going to have the pipe exposed, and it looks pretty cool.
Or also I think for the MRI rooms, Jim, because of the because of that as well.
Excuse me, yeah, it can be used there. The MRI rooms, that's a real interesting animal right there in putting these things, because it's magnetic resonance imaging. So So the system itself, the MRI unit, when it's operating, what does it do? It becomes a magnet. And if you've got anything in your sprinkler system or in your sprinkler that is attracted by that, it will eventually go towards the unit. So you have to use very specialized MRI type sprinklers. We got a few of those that are listed for use with MRIs. So that's a real specialized area you have to be very careful of when you're putting that in. But basically black steel, type KL or M copper, basically that's the wall thickness, or CPVC piping, orange Glazemaster type piping. That's what we're going to do training on when? Next month, Will?
Yes, well, that's actually got postponed, so we're going to have to
on that one. So those are the three basic types. Now, with black steel, there's Schedule 40, Schedule 10. There are other listed in the steel family. You can use a bunch of different types of wall thickness. One of the things that one of the things that piping and tubing impact is the ability to deliver water. Because as water is flowing through a pipe, you have to remember that sprinkler has to get a certain amount of pressure. Q equals K times the square root of P. So remember that you have to deliver a certain amount of pressure out to that sprinkler to get it to operate properly. Well, one of the challenges with that is, as water is flowing through the pipe, it's rubbing up against, those molecules are bouncing up against whatever the wall material is, okay? And that wall material can be black steel. So you're going to lose pressure by what we call friction loss. Simply by water flowing past the walls of this piping, it will lose pressure. And it will lose pressure at a specific rate that you can calculate. All right? So one of the things we have to be careful of is that each of these different types of piping have different friction loss characteristics. So why would you use copper? Because it's got great friction loss characteristics as compared to steel. Why wouldn't you use copper? There it is. There it is again. Right. It's expensive. Okay? So why wouldn't you use plastic? Why wouldn't you use CPVC? Lots of different reasons. It may not be listed for exposed. I mean, it's usually got to be placed in many cases, it's got to be placed behind walls. All right? It's not listed to be exposed in some cases. In some cases it is, depending on where you go. So steel pipe becomes the least expensive, most prevalent, but we have to be careful of its friction loss. So using the calculations, we got to make sure we got enough water. All right, then hangers. We have to attach this particular system to the building. So there's two things we have to be careful of when we're attaching the system to the building. Number one, we have to ask the question, how are we going to hold this thing up? And if the ground moves, how do we keep it from falling down? So those are the two things that we need to be careful of when we're attaching the sprinkler system to a building. Now, depending on the structure itself, we're going to be using different C-clamps, perhaps. If we're attaching it to a steel building, we're going to be using just drive screws or screws. If we're attaching it to wood down, if it's a concrete building, we're using powder-driven studs, things like that. Different anchoring techniques. This particular item here and this particular item here, which is where they attach to the building or they attach to the pipe, got to be listed for use with that as well. So basically the hangers we just need to be aware of. NFPA 13 has considerable requirements for them as well. And then there's bracing. Okay? Now this is not a hanger. This is bracing this pipe, and here's another one right here bracing that pipe against the movement, seismic movement of the building. Not a big deal down here in Florida, but pretty big deal around most of the rest of the country. In fact, South Florida is one of the only areas that is not really in an earthquake zone in the entire country. South Florida. All right, you get up even into North Florida, and you're into zones that you could require seismic bracing.
So
All right.
Some of the military projects we do down here require it for bombs, Jim, or for blast.
Military
bracing.
requirements. Military bases are going to require them simply because it's the military, and they build to what's called a mil spec, and they say done. We're just doing it.
Okay.
Okay. These are high emergency buildings, and and basically very highly important buildings that we don't ever want anything to happen ever to the sprinkler system in. So we're going to brace them. That you may find them here.
It's not often, but that's typically where I'll see it.
You may find them here in emergency response type buildings. You may find bracing in the building being required. Certainly the military is going to go down that path. But basically what these are doing is these are bracing against the building. So as the building moves, this system moves with the building. It's braced to the building. And it's important to do that because in cases where you've got earthquakes and the building starts to move, you want to brace it to the building so that it doesn't bang against the building. But then there's a whole other science behind the flexibility between floors. So we can talk 2 days just on seismic design because you got to brace this correctly and in the right locations. Then you got to provide the flexibility to the system where it crosses over between floors. It gets pretty detailed and very interesting as to how the science works there. But pay attention. That's the only other basic attachment that you're going to find, from the system to the building. You've either got hangers or you've got braces. Hangers protect against gravity. This protects against everything else. Control valves operate simply by they control the water. So they are indicating that they are either open or shut. And there's a couple of different ways that they're done. They have to be listed, okay, for controlling. They have to be listed for controlling water into the building. So open, chained open, sealed. This just means that water's flowing into that system. With this is called a post indicator valve. In this case, it happens to be on the wall, so it's a wall PIV, and it has a window that shows you the exact setting of the valve. In this particular case, we have a OS and Y valve, or an outside stem or outside screw and yoke valve, and it is informing you that it is open simply by virtue of the fact that you can see the screw here. So if that's a 4-inch valve, then you should have 4-inch stem extending beyond the wheel, indicating that it's fully open. In this case here, this control valve, butterfly control valve here, it is also indicating, here's your flow here, and here's your indicator here showing me what?
Closed.
It's closed. Okay? In this case here, when I turn this valve, that indicator needs to be parallel to the pipe in order to indicate that it is fully open. Anything in between there becomes a bigger issue. All right? It becomes an issue of being partially closed. And the reason that you want to make sure you pay attention to that, everybody, is because when it comes to that, and when I talked earlier about that 95% success rate for sprinklers, well, in that 5% of the time when sprinklers don't operate, 2/3 of that time is because a valve is closed or partially closed. Okay? So control valves become a huge focus when you're doing an inspection of an existing system. They become a huge focus. Make sure your valves are open. Then we get into check valves. Check valves basically prevent water from flowing in a specific direction. Allow water to flow in one direction, prevent it from flowing back. All right? We use them to segment off certain parts of the system, but primarily they're just, they're basically used to allow water to flow in one direction. And if we have on almost all of our systems now, we've got backflow prevention devices. Mainly because the water authorities don't trust that. Okay? They don't trust a single check valve to prevent water from flowing back. And they don't like our water getting back into their system. Back in the early 90s, we fought this battle for a couple of years. The sprinkler industry did, when I was representing the industry. There was just no fighting the water authorities. They screamed public health and we were done. We said, okay, help us out. The big challenge here with backflow prevention devices, number one, this is a reduced pressure zone backflow prevention device, but primarily the biggest challenge here is if you're retrofitting them on a system, they have a pretty significant friction loss in and of themselves. So if you've got a system that requires 15 psi at the most remote, and all of a sudden you're going to drop, you put this thing on, and this thing takes 15 psi away from the system, what do you got at your most remote sprinkler? 0. So what do you wind up doing? The big challenge, right, the big challenge was never really about putting these backflow prevention devices on. This is a one-shot deal. They're not terribly expensive, and they don't take up a lot of space. But suddenly what you did is you called it, you impacted the water supply. Now you need a $20,000 fire pump put on. So that was usually the big, once again, it was money. That was the big issue we had with them. It's like, yeah, no, you don't need to do that. So retrofitting became a big deal. With new systems, you can plan for it. Okay, yeah, I got to have a fire pump in there. But the backflow prevention assembly, you will find, a lot of them are outside down here, right? Yeah, it's nice.
Almost everyone.
Well, you put one, not up north. Not up north, baby. You have to put those inside. So, I mean, another part of the problem with retrofitting was where are you going to locate them? You couldn't find a space. You couldn't find space for them. But now we design them. Now we design them. Then you get drain valves. Subsequent areas in specific systems need to be drained, especially in low points in dry systems where we don't want water in the system itself. So we got to drain it. We're going to have auxiliary drains, and inspectors test connections where we're going to flow water. We are going to imitate on an inspection the flow of a single sprinkler, and we're going to find out how long it takes for us to get any kind of alarm in the system itself. So sprinkler control valves indicating or signage indicating what those valves are. Very important as far as inspection, testing, and maintenance is concerned, because that's going to be one of those, you go back and say, all right, what is this valve controlling, or what is this valve doing? Fire department connections, 2 different types. Providing water, either a Siamese connection or 6-inch or 5-inch, a quick connect onto those particular items. Again, you're basically doing that based on whatever the local fire department uses. You're going to be installing that type of a connection. The paddle. Now, basically, one of the ways that we indicate that water is flowing is through a paddle type water flow device. One of the ways we can do that is, and I think we can show you one on a riser outside, is that it's just a simple check valve to the system, and then we have a water flow paddle here on a wet pipe system. And basically the water flows past this paddle or this indicator, closing the circuit in the unit here, and it goes off and shows the, it goes off and provides the alarm. And then the alarms outside are either water flow alarms, big old water flow alarms where actually water is being diverted from the system, comes up through the paddle, spins the paddle here, clangs the bell on the outside. Or it can be an electric bell once the circuit has been closed. So let's take a minute here then, and we'll just kind of go through the different types, and we can take a look at them outside before we're done here. And actually, we've got a lot of nice posters around the room too, describing all of them. It's going to look pretty familiar here when I put them up on the slide. But basically, the single, basic, easiest system, simplest system is the wet pipe system. Right here, we've got the easy riser set up here with this particular valve, and primarily it's basically a check valve. Comes in, you got a water flow alarm, you got a water flow indicator up above. You're looking at pressure gauges on these particular systems. All right, water pressure down below, air pressure up above should read the same, maybe a little bit higher on the system side. And basically just water is already all the way in the system. One of these around here. This is what it looks like. Okay? Water's already in the system. In this case here, it got diverted off into a retarding chamber and then out, and basically this was the one component we saw. Water flows by, spins it, bangs the bell after the system has operated. In a dry pipe system, we'll see two of these valves out there as well. Take a look at each of the different ways that these operate. Primarily what we're looking at here on a dry pipe system is because there is no water in the system, in the piping itself. There's a couple of things that we need to be very aware of when we're looking at this. Number one is the pressure gauges. What's the story that the pressure gauges are telling us? All right, we'll talk about that in a minute. Pitched pipe, we want it to drain. We need it to drain. A dry pipe system needs to get drained to the water, so we need to pitch it back to a drain, whether it's an auxiliary drain as we showed you, or it's all the way back to the system riser. Certain types of sprinklers, we typically go with upright sprinklers on a dry system so the water can be completely drained out, although there are certain circumstances where you may run into a pendant sprinkler off of a dry system, but there are other arrangements, other installation rules that govern that. These tend to be limited by system size, and what we mean by that is the area that it covers, or not necessarily the area that it covers, but the capacity of the piping within it. 500 gallons total capacity or 750, and it's all based on water delivery. All right, so water delivery becomes a big issue. Remember, there's no water in the pipe. So when the sprinkler operates in response to a fire beneath it, the first thing that comes out of that sprinkler is air. It ain't gonna do anything for the fire. So the big concern is how quickly can we get water to that most remote sprinkler. That's why the inspector's test connection on a dry pipe valve has to be at the end of the system. Okay, so in that case we use, in order to kind of get that particular air system out there, we use quick operating devices or accelerators. And we talked about the protection of the piping or the area, and then also we need to provide a level of air supply pressure to keep the valve closed, differential dry pipe valve. So in this particular case here, we see this particular valve has a setup here, and as I told you before, these gauges will tell the story of this particular valve and its arrangement and its settings. So in order to take a look at that then, we see that we have a water pressure here being read by that valve, air pressure here, or by that gauge, by this gauge here, and then we've got a third gauge up here we'll talk about in a minute. Okay? So in this particular case, we see that what we've got here is, looks like about, what, 40 psi up above? Kind of hard to tell what we've got down below. But what we should be seeing here is actually the air pressure being lower than the water pressure coming up from below. Okay? So, and the ratio depends on the type of valve. So it's a 6-to-1 ratio or a 5-to-1 ratio, something along those lines. If I've got 100 psi coming up on top, or if I have 100 psi of water pressure coming up underneath, should be able to hold that close with a 5-to-1 ratio of about 20 psi on above. Okay, so the air pressure gauge should always be reading lower than the water pressure gauge, depending, and it depends on it depends on the ratio that the valve is designed for. And then this is an accelerator here, and I'm going to show you how this works in a moment. But the accelerator's gauge should read the same as the air pressure gauge. I'll show you why in a second when we get to that. Here's the accelerator, the inside of the accelerator, and this is set at, this particular gauge will be set at system pressure. All right, this chamber. Because what's going to happen as the system reduces pressure, this valve will operate, because this is closed off. So pressure will start to reduce here, this will push down, and the air pressure from the system will then be diverted back underneath the valve and help it operate. So if we take a look at one of our diagrams around here, shows that particular one as well. Pre-action and deluge systems, once again, both of these systems are automatically operated or mechanically operated. They have an interaction with the alarm system. Okay, that's the key here, the releasing devices. So the pre-action system basically is a closed system. All the sprinklers are in place. You wouldn't notice anything different about the system necessarily. It's just that it operates as a dry system. There's no water in the piping. It operates interactive with the alarm system. And if it's what we call a double interlock system, pre-action system here, basically what happens is the alarm devices go off. Here's our system control valve. This is actually a deluge valve right here. It's just wired a little bit differently. Water flow pressure, water alarm motor on. All of these go down through. You can see them on your diagrams as well. But primarily what we have here is number 8 is a detector. And so this detector here, when it operates in a double interlock or in a single interlock pre-action system, basically what's going to happen here is either the sprinkler system will operate in a single interlock, or the detector will operate and water will come into the system. On a double interlock, you have to get both the detection device and the sprinkler operating before water flows into the system. And these types of systems are really specialized. We use them in places where you really don't want water flowing unless there's a fire. So any place you can think of that's highly sensitive to water getting into it.
Server.
Excuse me?
Server group.
Yeah.
Normally.
Yeah. And so any of these locations that lots of people use these pre-action systems when they really don't want, like libraries, museums, places like that they really don't want any water getting into the system. Deluge system is again, same valve. If we go back to the pre-action system, it's a deluge valve that's being used, mainly because it's being mechanically held shut, but there's no water in the pipe and all the sprinklers are open. So as soon as that thing operates, this is not operated by anything other than a detection device, and as soon as that goes, the entire system dumps. Aircraft hangars, things like that might be spaces where you could see something like that being used, but it's a mechanical valve and a detection system there. Other types of systems, some of them not really used anymore. Antifreeze systems, not permitted. We're not permitted to use antifreeze in systems at all under NFPA 13. If you have existing antifreeze systems in buildings, they are permitted to be used under the guidelines of NFPA 25. Circulating closed loop systems, these particular systems take water off of other, heating systems and things like that are already in there. Don't see much of these ever. They were used or came in about somewhere in the 80s. Don't really see these being used, but these actually take they take water from closed loop heating systems and things like that for the sprinkler system. Outside systems for exposure protection, you find these, a lot of times you'll find these at the airport, perhaps, where the windows are looking out on the tarmac, and people, they'll choose, in order to provide the protection, you'll choose outside sprinklers to spray down the water down the windows. Refrigerated space protection, we talked about that earlier with the either dry systems or the dry drops from wet systems. Commercial cooking equipment, up not only just the equipment itself, but also up into the grease ducts and up into the grease hoods. It is permitted. It's not really one of the best ways, to be honest with you, to protect commercial cooking equipment, mainly because those are grease fires, and water and grease don't really mix that well. They don't interact that well, but they are permitted to, they have been permitted and been installed in the past. Okay, well, thank you for your time. We can walk outside and take a look at some of the valves if you'd like, do a quick tour, but I'm done with that part of the presentation. Great. Thanks.